GMs. Today I'm going to show you Fluton, the Universal Confidentiality Engine for Digital Economy. For context, I'm John. I'm the core contributor to Fluton, and my background is in computer engineering. I've also been recently accepted to Technical University of Munich for my master's in computer science. I've been working in the Web3 ecosystem for over half a decade now, and before working on Fluton, me and my team built a venture studio style initiative where we supported early stage Web3 projects for both in technical and business development execution. And with the budget we collected, we decided to launch our own project, which is where we are today. So the problem we are solving is the lack of privacy problem on blockchains. Since blockchains are transparent by design, you cannot do any kind of confidential transactions on them. But we believe that for mass adoption of blockchains, confidentiality is the key. Just like no one can see your bank account balance or history right now, this same principle should apply to on-chain transactions as well. We'll solve this by introducing encrypted intents into the system. With the help of encrypted intents, you'll be able to do confidential transactions such as confidential swaps, staking, lending, borrowing, bridging, and so on. With this version of the MVP, you'll be able to create an encrypted intent for sending your tokens from one network into another while keeping the amount hidden. So let me quickly show you what we built. So first step is you need to claim some tokens from the faucet here. I already have some tokens in my wallet, so I'm going to skip this step. The next step is shielding your tokens. We cannot use normal traditional ERC20 tokens in the system because they are transparent. So that's why we adopt ERC 7984 standard, which is also known as the confidential token standard. So let's, for example, shield some USDC on Arbitrum Sepolia. Let's shield 10 USDC here. So after I click shield, I wait for my CUSDC, which stands for confidential USDC, to arrive. And after my tokens arrive, I'll be able to start doing confidential transactions now. So for example, let's send some tokens from Arbitrum Sepolia to base Sepolia. And when I enter an amount here, I basically ask the solvers, which are running behind the scenes, to give me their offers, but I don't tell anything about the amount I'm sending to the solvers, so they are giving their offers blindly. For example, this solver said they will take 0.005 USDC as fee. So if I accept this offer, if this offer is suitable to me, I can click this transfer button, which is going to encrypt these numbers you see here before submitting them on-chain, because on-chain is public and we don't want to show this public data on-chain. So let me approve this transaction. And after we encrypt these numbers, we are submitting them in encrypted form on-chain. So let me quickly show you as proof. So let's take a look at the transaction details. And if I press click to show more and decode the input data, you can see the transaction details here. You will see, for example, the sender, receiver, relayer, and so on. But the encrypted input amount is completely encrypted. As you can see, this is not the amount I entered on the front end. The output amount is also encrypted, as you can see, and the destination chain is encrypted as well. So nobody can tell how much tokens I transferred to any chain. So yeah, my intent got fulfilled in 15 seconds, which is a plus side of the intent-centric architectures. So this is how we send tokens confidentially from one network into another. And let me actually show you another cool feature we are building right now. And this is going to be the yield page. And this is where you are going to be able to generate yield confidentially by interacting with any protocol you want here. We are working on a smart contract called the confidentiality adapter, which works as a middleware between you and the protocol. So you interact with the intermediate contract, which is going to keep your intent confidential. So thank you for listening.